All right. Welcome everyone. Welcome to Qflow Spark Operator community call. But we used to call Qflow Spark Operator until now. But from this year, there is a little bit of a change, and that we wanted to focus more on anything related to Spark on Kubernetes. We also published a bunch of repos that we will go through that as a part of today's discussion. So our focus is like Spark operators mainly, that everybody is part of that group. And we also have other projects that we built, MCP server for Spark History Server, which is again, part of this group and which will be used, you know, basically for doing the building your AI agents, for debugging your Spark jobs, and we are also focusing on other bits of accelerating Spark, like Apache Data Fusion and Apache Caliban, which runs on Kubernetes. So this community is going to discuss anything related to optimize your data processing workloads on Kubernetes. So we can discuss all of those, and not necessarily this maintainers can help you in every single aspect, but as a community, we can help each other on this. That's the goal for this year. But just to give you an intro for everyone, my name is Varabuntu. I work for AWS as a principal open source specialist essay. And then today we have two maintainers here along with me. Andre, do you want to introduce yourself?
Yeah, sure. Yeah, also I think we should just remind that this call will be recorded and also going to publish on
Yeah,
YouTube. And as always, like we follow CSF code of conduct, so please be welcoming to each other. But all in all, like my name is Andre, I work at Apple. Been involved in this community for like 7.5 years since like very beginning. Working in many different areas over the last period of time. And right now, focusing on training, inference, fine tuning, and do a lot of data processing internally. So we're managing the Jupyter-based platform, and we have a lot of knowledge around Spark and other data tooling on Kubernetes. So exciting to talk about it with you. Um,
great.
yeah.
Manav.
Yep. My name is Manabu Maklowski. I am a senior open source engineer. I work with Vara at AWS as well. So I have been a maintainer for over a year now, and happy to answer any questions.
Okay, great. Uh, that's pretty much. And today is the 9th of Jan and 9 a.m. PST. And I think with that, we can kick off the introductions. And I know there's a lot of folks who are new here, but if you wanted to, you know, come on a camera, want to introduce yourself, and we can spend some time. We would like to see your collaboration. So feel free to come on a camera and talk about just give what you do and why you're interested in this group.
Well, okay, I can start. I'm
Yeah.
Andre's teammate here from Apple. Do a fair amount of technical support, including supporting customers on with our integrated Spark offerings on Jupyter. So that sort of enticed my interest in this call. Nice to
Thanks.
meet you all.
Thanks, Peter.
Uh, Here, I can go next.
Go on.
Um, Hi, this is Akshay. I work at the same team as Andre and Peter here. So primarily been with Apple for 5+ years, spending time building data infra, interactive data infra, and ML infra, and a part of the Kubeflow org, where I've started distributed cache for training workloads, and which I'll talk about later.
Thanks, Akshay.
Can I go next?
Yeah, go on, Chitra.
Hi, this is Chitran. Actually, it's Chitranga Pisati, and I have been working as a DevOps engineer for Safeway Albertsons, and recently, for over past 3 to 4 months, I have been doing a POC, and that's where I got introduced to Spark Operator, and I have many questions and a few suggestions as well. So that's why I have been joining this call.
Yeah, great, Chitran. Let's keep
Thank you.
that some time for your questions at the end.
Thank you.
Yep. Next.
I can go. Hey guys, this is Shashank. I'm joining from NVIDIA and a platform engineering team. So we heavily use Kubeflow and Spark on Kubernetes here. So this is my first call, just trying to like join and learn what you guys are working on and hopefully contribute as I go.
Thanks, Ashank. Next, who wants to go?
I can go next.
Yep.
Hey everyone, I am Rafi. I am on the data infrastructure team at Affirm. We are actually quite heavy users of Spark as well, and we recently started like publishing and publicizing the Spark MCP server, which has been actually very useful for some of our workflows.
All right.
Yeah, I can go next. Hello, everyone. I'm Siddharth. Sorry, I can't. I can't switch on my video. I'm in transit. I'm a principal architect at Salesforce. I lead the compute data platform at Salesforce. We do run a very high number of Spark jobs, almost close to 4 million jobs a day. Across hundreds of EKS clusters. Now we are looking at how we can, accelerate Spark using native engines like Velox, Gluten, Data Fusion, Comet. We are also trying to evaluate Kelebon, Unicorn. So that is where when I interacted with Avara, that got me excited. So happy to be part of this group and learn what you all are doing.
Thanks, Siddharth.
I can go
Next. Sure.
Here. This is Supreet here. I'm a senior data engineer at GoTo. I've been working, I mean, this is my first call, first time exploring all of this. So I've been working closely with, when I'm trying to build MCP servers to help our stakeholders interact with the data. And I was trying to think about how do I get that to interact with the Spark History server. And that's when I came across this. So yeah, that's my first.
Thank you.
Hello, I want to go next. I am Yash. I am an engineering student currently, working as a backend engineer and looking forward to explore more about Kubeflow and hopefully contributing to it as well. So
Thank you. Anyone wants to go next?
Okay, so hey everyone, greetings from this side. I'm Jayaprakash, undergrad from India, and yeah, I'm also here to learn from people like you. Like, yeah, thanks for having me.
Yeah, thanks, Shay. Anyone else?
Hi, for quick introduction, I'm Marco. I'm a software engineer at Datadog, and we use the Kubeflow Spark operator, and we're starting to add on more offerings like Spark Connect and the MCP server. So first meeting, but it's good to hear what's going on and be up to date.
Thanks, Marco.
Hello, this is Jeffrey Du. I'm from the Imperial Computing. But my time is spent on the Kubeflow porting to so make sure support on 64.4. Nice to meet you guys.
Thanks, Jeffrey.
I guess I can go next.
Yeah.
My name is Zemin. So I'm like a data engineer working for ASEAN, and we are looking to this Spark on Kubernetes, and also we onboarded this Spark MCP Spark history server. Yeah, really nice tool, I would say.
Thanks,
so much.
I know we talked on a lot on Stack. Thanks for your contribution to MCP server and everything. Really appreciate it.
No worries. Happy to help.
Anyone else wants to go? We can give a couple of minutes.
Hey guys, I'm Samir. I'm from BITS Pilani, India. So I'm an undergrad student and I'm relatively new to Kubeflow community. So I'm just here to see what this all is about. Thank you for having me.
Sure, you're gonna learn a lot. Thanks, Ray. Okay. I guess we're good. If anyone wants to jump in, jump in. Otherwise, we can kick off the first session. Firstly, I think the folks who joined a little bit late, just to give a bit of background uh, for everyone about Kubeflow Spark Operator. Kubeflow Spark Operator was originally, I mean, it used to be called as a Spark Operator, created by Google and a few other folks, and it's part of the Google uh, org. And then there's a lot of organizations have been using Spark Operator in their in production, but they faced some issues around maintaining the repo because they didn't have enough maintainers to maintain the Spark Operator. So that's when Apple folks and myself from AWS and Google, we all got together and requested Google to actually donate that to Kubeflow community so that we can bring a bigger community for Spark Operator. That's a kind of a story where the Spark Operator came to Kubeflow Spark Operator. And Kubeflow Spark Operator is written in Go, and most of you know originally. So, and since it's moved to Kubeflow community, I think last year, and we have been actively maintaining it and added features to, which is at par with Apache Spark versions today. And one of the key contributors, and we had key contributors, but they are moving on to different roles. And there's one maintainer that I wanted to mention who is not in the call. He's very active on the repo itself. His name is Yichin, and he's from Alibaba Cloud, I guess. So he's actively maintaining along with us, and we have Manabu, myself, and Andre, and then and few others are part of this group. So our goal is to bring more folks into it. Now, Spark Operator is not a huge project, and if you are passionate about Go and passionate about Spark, want to fiddle with this repo, go ahead and try it out. And the instructions are really good in terms of how you develop and modify the Spark Operator for new features. So you can get on and play with that. And if you have any questions, especially for the folks who wanted to learn and, undergraduates and anyone, you could definitely give it a go because this is one of the operators within Kubernetes. So you could, you can learn a lot about that. Right, that's for the Spark Operator. The history of the Spark Operator, and we just for someone who wants to use this in production, this has been in production for like I would say hundreds of customers for sure. But I myself work with loads of customers who are actually running this in production. So you are in safe hands in terms of using Spark Operator, but there are cases where customers who the users or organizations who are running at a very large scale, they have some concerns around, job submission rate and so on. That's the area, I guess. We have some Salesforce folks who did a lot of work on improving that job submission and try to create a plugin. But hopefully, we can bring them back to present the solution that they've already done it, maybe in the next call or so. Apart from that, it's pretty stable for you, but unless you think if there are any features that are missing, and we haven't drawn the 2026 roadmap yet. So in 2026, and mostly wanted to see what are the key features that we want to add and where we want to focus on. And apart from the issues and critical issues that you are facing, other than that, and then you can pick and choose the areas that you wanted to contribute for that 2026 roadmap for Spark Operator itself. Right. So we don't want to stop at Spark Operator this year because everyone who comes with the questions this is great, and Spark Operator is being used in production. But then again, there's a lot of components within Spark where users are interested in, like Siddharth from Salesforce mentioned about they wanted to accelerate Spark. but there's a lot of plugins out there because this community is very active on Spark. And why can't we actually share, the acceleration or the benchmarks that we ran and help each other to run and accelerate on Kubernetes? The key reason is right. So everyone want to optimize the cost. End of the day, when you are working for your organizations, and the main motive is optimize costs and improve performance. And these are the two areas where the plugins comes into the picture. So for that, we have a bunch of them, like Apache Data Fusion, and Akshay is going to talk about it in a minute. And we also have Apache Gluten and a few other plugins, I guess, but these are the top two ones. And outside that, we also have a topic around Apache Caliban, which is for remote shuffle service. Because a lot of the folks are interested in remote shuffle services, but they all type to Spark. That's one of the reasons. One thing just to clarify, everyone, this is, I know these projects, Gluten, Data Fusion, and Apache Caliban, they have their own community calls. They run their own project, but we are not trying to overtake or trying to mix everything here. But this is, we talk about anything related to scale those workloads, integrating Spark operator. So that's the key thing. But if you really want to dive deep into individual projects, I would ask you to work with the specific community like Data Fusion or Gluten or even Apache Caliban. That would be the better place in that case. Yeah, Andre, go on.
Yeah, I think I just want to add like a few small points around this. So yeah, like we during our like discussion with Data Fusion folks, yes, there are definitely separate communities and there are a lot of work going on there. I think those communities really exciting about our initiatives to run those things on Kubernetes specifically, because like historically, all those Apache tools, they've not been really designed to run on Kube. And I think we have like unique positions here to actually give them some sort of gateway to run this at scale on in enterprises, because many organizations run today Kubernetes, but not like there are still challenges to run those workloads on Kube. So I hope like we can engage with Data Fusion and Gluten folks to maybe come to this course and maybe give a demo or an overview or like some sort of discussion points how we can better run those workloads, right? Because I think they are still very challenging, right, for migrating for all those users.
100%. That's a really good point, Andre. So it's Apache Caliban is a good example that Abu and I are recently trying to run some benchmarks, and hopefully we might share some of those benchmarks very soon in a few weeks down the line. And there are some challenges running same Caliban on Kubernetes, right? So, but compared to running on a bunch of VMs, so anything, all of these Apache projects run on Kubernetes might have some challenges, but those are not, that is something that we can solve with this community. That's the whole idea. So, like we discussed, Spark Operator is one of them, which is a core for this community, and then we will focus on the acceleration projects like Gluten and Vlogs, and Caliban, which is for resiliency for Spark. And then the key point is about AI agents, right? Mostly everyone is now today is trying to work on AI agents and using whatever the tools that you're using today. But debugging Spark is the area where you need some metrics on the Spark to do the debugging. That's where we build this MCP server for Apache Spark History Server. So that's going to be part of this community more actively. So Manabu and myself are currently maintaining this, but we welcome more folks to become part of this community repo, especially, and then become a maintainer or contributor to that. And if you need any help, we can. But that's mostly these MCP servers are pretty stable, unless there is a protocol change, unless there are, Spark HT server itself is for many years. There are no changes to it. But if you think if you can improve the performance in terms of how we designed, and there is a scope in MCP server to Spark HT server where you can look into it. Right, so that's a kind of an intro. If anyone has any questions, otherwise I will ask benchmarks for Spark Operator. Right.
Yeah,
So
I think I just added this
let's
to the topic, so you'll be talking about the
okay.
benchmarks. I think there are a couple of good things we've done over the last year. I think this is the blog post I probably published about Spark Operator benchmarks. And also, I think I published a roadmap doc and the MCP server repo, so folks can get engaged there. I also, I think, maybe want to say that if you have some topic you want to propose, feel free to use this meeting notes for the future meetings. Currently, we're going to have this call bi-weekly on Friday at 9 a.m. So if you want to present something or maybe talk about something, feel free to add this to the agenda items in the future, right? And we can just talk about the things. And we also have Slack channel and the calendar for the invites.
Right. Thanks, Andre. So these benchmarks we ran last year, but yeah. So there are there are not many changes since then. But if you think this toolkit is available, and if you want to repeat it and you want to test it in your organization that you want to ensure, you can always do it. Pretty straightforward. You can also look at some dashboards as well. Yeah, so those are the benchmarks for Spark Operator, but we will also share the benchmarks for Gluten and all other projects as well here, maybe later on. In the next call, I will discuss a bit more around that. Cool, right. So moving on to MCP server for Spark server, and I guess a lot of folks here mentioned about that you are already using it and you are interested in it. But if you like the folks who are today building SRE agents or DevOps agents, and that's very popular nowadays, and these agents on Kubernetes, and they're already Kubernetes related MCP servers, but that is actually not sufficient to debug Spark and applications, because Kubernetes only gives you some logs from the Spark pods, but doesn't give you some metrics and the detailed JVM usage of what Spark applications are running. And if you want accurate way of troubleshooting your Spark jobs running on Kubernetes, and also optimizing your job, like where you want to improve the, let's say, over provisioning CPUs or under provisioning memory, and so on. Those are the areas where Spark S3 Server comes into rescue. So it's just another component within the agent when you will. We have another project I'm gonna share. That's a sample, like a project which will show you how you can integrate MCP server for Spark S3 Server with logs, your Spark logs. The logs can be anywhere. You can point to any of the vendor-based logs, like you have, Dynatrace or Datadog or whatever, or you have the logs in S3 or CloudWatch logs, and then that combines with the Spark S3 server to give you an accurate troubleshooting for your applications. It's a goal, but I would let Manabu to talk a bit more about Spark S3 server, and then we'll take some questions and before we move on to roadmap.
Yeah, so it's a Spark History server, also MCP server for Spark History server. I know it's confusing with the naming and everything, but yeah, it is a MCP server designed to be used by the agents of your choice. It should allow you to be integrated to a lot of different frameworks because it's just a MCP server. What it does is it's just going to talk to your Spark History server. If you're a Spark user, how you can leverage the Spark History server to look at the job and the stages and all that information based on the whatever metrics you have. So, and essentially this allows you to query all the data using natural language, and allows you to debug, also to troubleshoot your any Spark issues you may have. Yeah, that's the MCP server in a nutshell. But yeah, if you have any questions, concerns, this call is the way to go. And also,
Yep.
if you can join, then please drop the messages or questions in the Spark or Kubeflow Spark the Spark operator channel, I guess. But yeah, that's about it.
Thanks, Manabu. And I guess we did a demo in the past, but a lot of the folks are probably new to this. But we can plan for a demo in our next call if you're interested. But there is uh, YouTube video to talk about this. You can learn. It's very simple to set up locally. All those intersections are part of this, so you don't really need a Kubernetes setup. You just need your Mac or any of the desktops, and you can start playing with that. Once you think, I think there's some of the examples here. Like if I go in here, um, say AWS, sure, the integrations, I guess. Yeah. So you can pick up any of those, and these are a bunch of frameworks that Stance Agents, LangGraph, Kiro, Cloud Desktop, and Amazon KCLI. So if you have a cloud, you can actually use your product cloud configuration to connect to MCP server. You need a Docker to actually spin up the Spark History server locally, and we have a bunch of examples, I guess, in this. Which will show you the successful tests and also failed tests so that you can play with, testing it. Once you get used to it, and then you can actually run that with, your actual environments running on Spark History server running on in production. Right. So there's another important point, and I forgot to mention that. But if you are using Apache Spark History server, but so far, I'm not sure what you folks are using it, but we don't have a dedicated project for Spark History Server to run on Kubernetes. So we did create one in the past. Is it under Helm chart, like I'm talking about? Yeah, so this is under my repo, but we've been thinking of moving to the Kubeflow. Maybe we can if required. So if anyone is building Spark History Server, this is the Spark History Server, which is being used by, I think, Microsoft, AWS, and multi-cloud thing. And I'm not sure if there is support for Google, but I'm sure that Microsoft folks added the support. So this is running Spark History Server as an additional add-on on your Kubernetes. And then, just one Spark History Server, which points to any of the block storage you have, like our object storage. And then you can run this independently, and the endpoint will be used as a part of your Spark History Server MCP server.
Yeah, it's just a Helm chart, yeah?
Yeah, it's just Helm chart. It's not a Spark History server, but we didn't have one, but people are building their own. So it comes in a handy if you want to use it. Right, go on to that. You have a question?
Oh yeah, yes. Thank you, Varun Manu. Right, so we did evaluate this, MCP server for Spark History server. It is very promising. So we are now thinking on how can we productionize this at our scale, since we are running close to 4 million jobs a day. Having a persistent Spark History server which has logs across all jobs will not scale for us. So what we are thinking is since hardly 5 to 10% of the engineers would be looking at these 4 million jobs, right? That means if you look at concurrency, hardly in any given day, maybe 10 to 20 engineers would be debugging these jobs. So we are thinking of can we ad hocly give given a task ID in a platform which is which kind of maps to one single execution of a Spark job. Can we ephemerally spin up a Spark History server for a given task ID, so that it can just point to that one single event log file for the task? It will spin up Spark History server and then engineer can just point his or her local MCP server to that dedicated Spark History server. And once the exploration is done, we can just tear it down. That is one exploration we are trying to do, where can we do this end to end per job and give isolated space per engineer. So one question on that is, does this tool require a running Spark History server, or can we just point it to an event log which was captured from the driver itself?
Yeah, so it does need a running Spark History server because we don't parse the Spark logs ourselves. Because that would be, well, we actually did consider doing that, but that would be a lot of maintenance headache. overhead for us, and we couldn't really do that. So we do rely a lot on we essentially rely on Spark History Server for all the data that we are getting. So, if you want to use the MCP server, you do have to have Spark History Server. Now, as for your, deployment considerations for using ephemeral servers and all that, I think that makes a lot of sense.
Yeah.
But the only concern I would have is the spin up time. As you know, the Spark History server can take a lot of time processing all these, data based on, especially your job sizes are large. For example, if you're like an 8-hour job, it might take, 10, 20 minutes for them to be processed. So that might be something that you want to be aware of before doing any of the ephemeral work.
Got it. Thank you, Manav. That is a good trade-off. We will evaluate whether it is okay for, let's say that if it is just 20 to 30 engineers accessing 4 million jobs, and at any time we are just, looking at a very small subset of jobs, does it make sense for the engineers to wait 10 minutes for the spin-up server? Or the trade-off is where we always run a long-running Spark History server, which is now accessing all the millions of jobs, and then your file listing becomes a problem. Yeah, but yeah, good point. We will do some further exploration and we will stay in touch.
Yeah. So there's the biggest performance concern with the Spark History server is, especially when you have hundreds of jobs and people trying to create one Spark History server, pointing to all those historical events and maybe hundreds of jobs, and then a Spark History server is not going to scale because it was never designed for that. So one thing we see for all the organizations too is to create multiple Spark History servers. So if you have multiple tenants and try to deploy one Spark History server per tenant and then reduce the scope of how many events that one Spark History server can, visualize it. But yeah, the transient Spark History server is a good idea. I felt like you can create and destroy it. But again, like Manabu said, there's a time if you have to give before the logs are available for Spark History server. But yeah, so even there is not much of I don't know if there is any scope, but there's not much of improvements going on in Spark History server in Apache Spark community. But there are some performance issues for the large scale data, especially when you run for hours and hours. Yeah. Thanks. Anyone?
Yeah. So I think there was another question from Zemin around your cadence for the releases. Do I have any kind of thoughts on how you're planning to release this Pipey package for the MCP server?
Yeah, we don't have a defined cadence for releasing it yet. If you look at the code base, it's fairly stable. But I do, I do want to release a new version soon because there were some improvements that we made, and we will also be needing to, update the dependencies and all that as well. But if you have any suggestions for cadence, I'll be all ears.
Yeah, I think those organizations who are using this server in production will be super useful for us to understand, what they need, what are the limitations for them to, to deploy this. Yeah, I mean, definitely having something like with the release branches would be helpful, right, for us to maintain its stable version. Makes sense.
All right. We just start to follow, maybe apply some Kubeflow governance here. Okay, cool. Anyone has any questions on Spark History server? Otherwise, we'll move on to Apache Data Fusion. I would take that as a no. So Spark operator roadmap, and this, let me open that. That's the roadmap. I think this is from 2025, and some of this stuff is already done, I guess, and we need to sit together. We haven't got a chance as a maintainers to see and create a 2025 one. Maybe we'll move the stuff that we haven't done as a part of 2025 to 2026. So I will share the roadmap, but if you think any of the critical features are, that is valuable to add in 2026, please feel free to drop in our Slack channel. We'll pick that up and have a discussion, and then we prioritize that. So, if you're interested to contribute back, and that's probably the green tick quickly. So it's about people's time to contribute back to those available features that we want to add. Right. So that's for the roadmap. And because we have 15 minutes, I want to give some time. So Apache Data Fusion. So Akshay, do you want to talk about?
Sure. Yeah. So let me share my screen. Just to give an overview of what we had. Can I share my screen?
Well, yeah, no, I think we should be able, because it's only one allowed to share.
I think now I can share.
Yep.
Can you all see my screen?
Yep, I can see it.
Cool. Yeah. So here, I just want to talk about the data cache project within Kubeflow Trainer, and specifically, so let me give just a brief overview of Data Fusion. So it is it's a query engine on Arrow data. Arrow is an in-memory columnar data format, and Data Fusion works with the Arrow data, and it's built in Rust. And so it's not typical like query engine, but it excels at providing interfaces so that anyone can extend the core interface and build your own data systems for your specific use case. And one such opportunity which we had is to build the data cache for large scale training jobs, distributed training jobs, specifically on using Kubeflow Trainer. So how we see this cache being useful is highlighted here, where when you have a distributed training job and you need to access a large data set, typically every worker streams the, if you take an example of PyTorch stream streaming data set, it typically streams entire data set across all the worker nodes, which in a DTP world need not be the case, and every worker needs to only have a specific shard of the data set. It only needs to see a specific shard for a training job or tuning job. And distributed cache, and distributed cache is where this will help by auto sharding the data set. So it distributes the data across every worker set, every worker, using Apache Arrow Flight. It again, it is a streaming data for gRPC based streaming API, which would minimize the data copy cost and excels at. So basically, it'll make sure that the only worker sees a specific shard, and also it specifically removes the hard deserialization time when let's say a Parquet file is being read directly by the worker. So the cache itself is built on Data Fusion, and it's deployed using Leader Worker Set API and Kubernetes. So we are you can configure the cache with n number of nodes, and for a specific training job. And we use Apache Flight to make sure that every worker node would only see a specific shard of the data. And during the bootstrap of the cache, let's say you use Spark on Kubernetes, for example, Spark operator, Kubeflow Spark operator, to to launch Spark jobs which can do data prep and store the data in Iceberg. And the beauty of this solution is that you need not worry about sharding of the data set before ahead of the training or starting of the training job, so that if you use cache, your data is auto sharded. When we bootstrap the cache, we auto shard the data. So and we make sure that every rank has its own set of data. And we have the architecture, and we have. I will also link the proposal which we had, which describes about the solution itself. And specifically with training workloads, what we do is when you can configure cache as a within your runtime, training runtime, and we provide SDK, Kubeflow SDK. You can use SDK to spin up, you will launch your training jobs, and with the training jobs, you can configure cache, providing an Iceberg URL. So that before the launch of the training job, we bootstrap the cache, auto shard the cache, and make it readily available for training job to stream the data with using Aeroflight. And we released, I think in the past November, we released the initial version of the cache with trainer, and this is the release talks where you can install with trainer and play around with cache. And feel free to open an issue or try out and let us know how it can be helpful for you.
Right. Thanks, Akshay. You talked about a lot about distributed cache, right? So, so do you know about data fusion, like that folks who are actively working on data fusion can talk about deep into data fusion for this thing?
Specifically talk
Sorry,
about Comet or
you talk.
yeah, good actually.
Yeah, specifically on the Comet side, I think
Comet side.
Yeah, Comet. So as a query engine, Data Fusion can also be used. So there's a project called Data Fusion Comet. So it accelerates the data movement for a large scale with Spark. It is a plugin with Spark, so that it can help with Spark workloads with the data movement within the Spark workload using in-memory columnar format. I don't have much insight on functionality of Comet itself, but it's a separate project under Data Fusion, and yeah, I think Data Fusion community can also help there.
Yeah, I think like what we want to say here, I mean, this solution kind of like, deeply integrate, because actually you mentioned about Iceberg, I guess like I don't know how other organizations managing their data, but right now there is a standard for a majority of folks using Apache Iceberg as the, like as the format to store their large scale data in Parquet. And the good thing about this solution, if you want to do, I mean, if you do your data processing with Spark and then you have your data sitting in Iceberg, we give you a way to actually process the data for your, training, fine tuning, hyperparameter optimization, or any other, like workloads you want to deploy when you need to have a pre-warmed set of data that you can directly put to the GPU. Because like the problem is today, if you have a really large chunk of data and you need to train your model, right now there is no simple way to do this without such solutions, because data increasing in memory, like you basically increase your GPU has a limitation of how much memory it can fit. And today some scientists, they maybe download the entire data sets in memory, then they partition data set within the memory, so they consume a lot of RAM and CPU processing time to do this, like to do this processing. But here what we say, like we have a data sitting in CPU in memory, and you can use this data directly in your GPU workloads without spending time of, like deserialization or partition or any other things that you could need to do before you start your model training, which is very efficient and especially valuable when your GPU cannot fit, like entire data set. Yeah, so that is why again, like back to the diffusion. Diffusion give us because it's query engine, it gives us a way to store the tables in memory rather than like in the arrow format. And I know like also we're doing the work to actually store tensors. I think actually do you want to maybe briefly mention about this? Like
Yeah, I think it's
yeah, go ahead.
yeah, yeah. I think in the next phase of the release, I think next phase of the project, I think we're working on how we can at least store the tensors from the data on iceberg table and feed it within the worker. Specifically, it'll be helpful specifically in the optimization job where they have multiple trials sitting on using on the same data set, because the training worker again prepares tensors specifically for each trial for every run. So we're trying to optimize that by caching tensors directly.
Thanks, Akshay. I think we have 7 minutes, and someone said when they joined the call that they have some questions and wanted to adopt Spark Operator. Is
Sorry, it was me actually. I was trying to raise my hand. I accidentally clicked on some of the button.
You want to go on now? So we
Yeah,
have
so
7 minutes.
I think it was mostly related to whatever now Akshay presented, but still I
Mm-hmm.
have so the proposal is to bring the same cache solution to the Spark operator, because as of today, if I'm correct me if I'm wrong, I was just doing the POC on the Kubeflow, and Kubeflow is a collection of different projects, starting from Kserve to Spark operator. Now, all of most of these projects can be separately installed as well. They don't. It's not like they go all together. So as of me, I have installed Spark Operator as a standalone project, and I have been working on as a POC on it. Now, if we are we talking about taking leverage if as a Kubeflow, if we install as a Kubeflow altogether, the trainer comes with the cache solution, and are we trying to take leverage of Spark operator to use the trainer's cache?
Yeah, so I think I can maybe take it quickly. So every project in the Kubeflow ecosystem is a microservice. So similar to Spark Operator, you can deploy trainer, like it's kind of controller, and you can, if you don't want to use, for example, pipelines or Kserve or notebooks, you can install all those microservices and deploy them in production. And then you can, mix and match things to say, hey, maybe I need to also like have my Kserve deployment there, or I maybe want to use cache. So all those things were extensible and portable. So like, which means like if you already have a Spark operator and if you want to try out cache, you can just install trainer and enable cache on top. So we have the instructions
Yeah.
there in the guides how you can enable it. Yep.
Got
Yeah.
it.
So right now, our cache is directly tied to trainer, and once you install trainer, it's an add-on on to deploy cache. But we have roadmap to actually separate out cache altogether so that it can be useful independent of training as well.
And
Got it.
I think also back to a question in terms of integrating cache with Spark directly. So today it doesn't support writes, it's only support reads. So you kind of like if you have your data from Spark sitting in Iceberg, and if you want to do large scale training, you can plug in this cache to perform your distributed training, for example, with PyTorch. So this is possible. But if you want to write data directly from Spark to cache, I think this is something we've been thinking about, because maybe you don't want to have this intermediate layer, of data storage, right? Like if you're familiar with Ray, for example, right? Like in Ray, you can do Ray data, you can store data like in memory, and then you can do training with the same Ray nodes. So the thing is like how we could do something similar with Spark and PyTorch would be interesting to explore moving forward.
Got it. And just to give you some context, I don't know whether this is the right platform, but the POC whatever I was doing when I got introduced to Spark Operator was trying to migrate few of Spark jobs from I don't want to take company's name, but one of the popular data analytics and AML platform. I was trying to migrate jobs from that platform to Spark Operator. And during that, that's what I noticed, that when I migrated those jobs, that performance was not matching what was in the earlier platform. I think the missing was the cache solution itself. I think I think we that's what was earlier starting off this call, I thought I was suggesting this one, but I think you are already on right track.
I think for the data processing, caching is not required for the Spark alone. If you're running just a Spark operator for data processing, we're probably talking about two different things here. And this caching is mainly for the distributed training, if you want to, use it together. But if you have any questions, you can feel free to drop in the channel. We can help you more
Definitely.
about that, because the storage concept is huge within Spark. If the old platform is using different storage and the new platform is using different storage, and you might have some issues. But Spark Operator itself is not going to slow down the execution of the Spark.
I agree with you. I think I might have framed it in wrong way, but I followed most of your documentation in the Slack as well, Vara, and I have been following your work for a long time. So we can have a definitely conversation in the Slack. I don't want to take this platform further.
Yeah, perfect. Yeah, anytime. Right. Thank you so much for everyone's time. And I think it's 9:58, so 2 minutes. And if anyone has any last minute questions I wanted to ask, and feel free to jump in. If not, we'll plan some demos from the next call onwards, and maybe we'll start with MCP server for Spark S3 server. So everyone who wants to see how the AI agent works on Spark S3 server and the logs, and we'll start with that. And then we'll start to showcase some of the benchmarks that we ran, Apache Gluten, Apache Kelibon. If you're interested in remote shuffle service with Spark Operator, we're going to show. But we might not fit everything in one call, but we can do one demo at a call. Yeah, that's it. Thank you. Have a good day and have a good Friday.
Yeah. I think again, like, please feel free to join our Slack channel. I think it's a great start. I think overall, like, we definitely, we want to hear from users and from end users, how they use Spark and other data tooling in production. So definitely, I think it's we can be in a good place to actually making sure we can run this on Kubernetes specifically, right? So there are definitely a lot of things to talk about. Thanks, everyone. Thanks, Vara, and other folks for presenting it.
Thank you.
Thank you.
Thank you all. Thanks for your time.